Dear student, in this class we are going to see the radiation mechanism of a two-wire antenna. Already for a single wire antenna we have seen this mechanism in the last class. Now particularly in this class we are going to concentrate on these two concepts. One is the formation of electromagnetic waves, that means how the electromagnetic waves are formed on the antenna, and the second one is how the detachment is taking place, how the detachment of electromagnetic waves is actually taking place in an antenna. So in order to understand these two concepts, let me tell you what exactly the antenna and how the electric field lines will be there on this antenna. So if you take this figure, as usual, this is a transmission line, it is a guided structure and it is an antenna. And in the last class already I told you, antenna is acting like an interface between a guided structure and unguided structure. What do you mean by unguided here? Unguided means free space. Free space and whose impedance is 377 ohms here. So this antenna is acting like an interface between your transmission line, which is a physical medium, which is a conducting structure and which is a guided structure, and the free space is an unguided media. Now if you take this antenna once again, I am connecting a voltage source at one end, because you know very well antenna is a wire which is excited at one end. That means I am exciting this antenna using a voltage source at one end. So as it is an alternating voltage source, whenever the source is given to this two-wire transmission line here, electric field will be set up between these two wires. And as it is an alternating field, you can expect an alternating electric field on the antenna. So if you see these lines of force is nothing but the indication of the electric field intensity which is actually creating on these two-wire transmission lines here. And the density of these lines, that if the density is more here, indicating that the intensity of the electric field is more. That means the density of the lines indicates the magnitude of the electric field that is existing on these lines here. And you know very well, my dear friends, electric field lines are always straight lines which originate on positive charge and terminate on negative charge. As it is an alternating field here, and initially if I assume that this is the positive charge here, on the other side it will be negative charge. So electric field always originates from positive charge and terminates on negative charge here. And as it is a alternating field here, once again it is going from positive to negative, again positive to negative, and positive to negative, again positive to negative. Like this, the electric field wave is actually be established along this line, and it is going to propagate from this place to this place. So from this to this, our transmission line is actually guiding it physically. And as soon as it is entering into this antenna is trying to radiate this information to the free space, because the duty of antenna is to radiate the information what exactly it is receiving from this. And remember friends, I would like to tell you what is happening inside also. What is a transmission line? Transmission line is nothing but a conducting structure. So inside the conductors you are having atoms. Atoms are indirectly having electrons. So a free electrons will be always present in the conductor, and then as soon as you are applying this electric field, that means your electric force is actually going to be applied in these electrons, and they are going to be displaced from one point to the other point like this. That means charge is moving from one place to the other place. Once the charge is moving from this to this to this like this, then definitely I can say current will be established, because charge displacement is nothing but the current. If the charge is displacing from one place to the other place, means I can say current is flowing. If the current is flowing, what happens? If the current is flowing, what happens? Then around the conductor, you can expect a magnetic lines will be like this. That is, circular magnetic lines you can expect here. And friends, remember here, if you understand it very clearly, electric field lines are in this direction, and the magnetic field lines are in this direction. They are always mutually perpendicular to each other. Electric field and magnetic fields are mutually perpendicular to each other. So that's why it is almost nothing but the property of an electromagnetic wave. What do you mean by electromagnetic wave? Electromagnetic wave means EM wave. So EM wave means I can explain here electromagnetic wave, which is nothing but a TEM wave. TEM, transverse electromagnetic wave. What do you mean by transverse? At an angle of 90 degrees. That means electric field and magnetic fields are at an angle of 90 degrees to the direction of the propagation. Suppose if the wave is propagating in this direction, let me say it is in Z direction, then the electric field may be in X direction, this may be X direction, and this may be the Y direction, the magnetic field will be there. And if you observe closely here, the electromagnetic wave is perpendicular to the direction of electric field and magnetic field. That's why it is called the TEM wave. Here also it is existing here. And if you observe closely here, your electric field variation is actually from positive to negative, negative to positive, and positive to negative, negative to positive. Like this is going on like this. So electromagnetic wave is established because of the electric force on the electrons which are present inside the conductor. So it is a two-wire conducting system. So that's why I may feel and I can conclude that definitely you got an answer for the first topic. What is the first topic? How the electromagnetic waves will be formed. These electromagnetic waves, once the electromagnetic waves are formed here, next we are going to say how the detachment is actually taking place here. So how the detachment is taking place? So if I want to just explain this, then please come to this figure. And if you see this figure, you are going to get an answer how the detachment occurs. So as usual, my dear friends, take this antenna. Antenna means which is excited at one end. Once again, it is a voltage source which is connected at one end, and it is an alternating field here, and electric field will be established as usual. So it is actually oscillating from positive to negative like this. Already waves are established here. Now I would like to tell you how the antenna actually sending the waves which are established on this transmission line to free space. That means how this wave on this transmission line is becoming a free space wave. So that thing we have to explain here. Now let me say, if you are taking this antenna and if you observe closely this antenna and this antenna, and if I cut here, suddenly if I cut here, that means I am cutting the mouth of this antenna like this, then you are going to see here. That means I have truncated like this. Once it is truncated, then there is no question of any conducting system here to sustain your electromagnetic waves. So definitely the waves has to leave this place. Once the waves are leaving this place, then definitely they are going to form closed waves like this. So for example, in order to explain this concept very clearly, I have taken 5 lines of force here. So in this case, I have taken only 4 lines of force. Whatever the waves that are actually releasing from this, at the point P0, if you observe closely, the velocity of the waves which are coming from this mouth to the free space is more than the light velocity. What is the light velocity? 3 into 10 power 8 meters per second. That is the light velocity. So naturally you are going to get here, it is C. And at this point P0, the velocity of the electromagnetic waves is more than your light velocity. And once they are reaching to this P1, this is the point P1, slowly they are reaching to the velocity of the light velocity. And once they are detached from this, there is no control to control these electromagnetic waves. Once the waves are detached from this, and there is no control of the charges which are present in this conducting system here. And here, as soon as you see positive charge and negative charge here, they are going to be formed a closed loops here. And I would like to explain in the next slide how the closed loops are actually comes into the picture. Now at this moment, understand that as soon as you are truncated this antenna, the waves are going to be released to the free space, and at the mouth of this antenna, then definitely you can say the velocity of the electromagnetic waves is more than the light velocity. Once reaching to this point P1, slowly reaching to the equal to the light velocity, and then it is going to enter into the free space, and the velocity of the waves depends upon the intrinsic impedance of the medium. Okay, once you understood that, then definitely I can give an excellent example for this, because in order to understand this mechanism, I would like to give a small example to you. Friends, you take a calm pond or otherwise a lake, the water is not having any type of disturbance, it is very cool. If you take a calm pond here, now you take a pebble or otherwise a stone and throw this stone to this water like this, what happens? Whenever you are throwing a stone into the water, and disturbance will be created here. So this disturbance will be in the form of a wave. That means as soon as you are creating a disturbance, this disturbance is propagated from this point of disturbance to the bank of this pond, and it is in the form of a wave. Suppose if you want to experience it, as soon as you are throwing a pebble like this, then put a leaf or paper onto this. This paper is going to be displaced from one place to the other place, that is in the form of a wave. That means waves are going to be generated. So this disturbance is actually reaching to this destination in the form of a wave. So exactly whenever you are creating a disturbance here, whenever you are giving a voltage input here, and there is a alternating field will be distributed here, and there will be a formation of alternating electric field here, and this electric field is going to be propagated along this antenna to the free space in the form of a wave, in the form of a wave. So suppose for example, if the disturbance is stopped here, you have not given any type of disturbances, even though you have stopped the disturbing the water here, whatever the disturbance is already created, it is already leaving this, it is already going like this. If you are adding one more disturbance here, that can be added in the future. Exactly, if you give this voltage and the voltage is turned off, but already waves are formed, that waves will be entered into. Then if you are going on giving the information continuously, another waves will be added to this after the time lag. Are you understanding this? So what I am telling is, once the voltage is given to this, and immediately if you switch off this also, once the disturbance is created here, the disturbance always continues its course of travel. It is going on doing this. Once the disturbance is created in the water, the disturbance will be reached to the destination like this. If you are going on doing the disturbance, what happens? It is going to give the continuous formation of the waves. That means this antenna is nothing but a creating of the disturbance continuously in the water. That means you are giving the voltage at this point here. So it is going on it is going on forming the electromagnetic waves here. These waves are going to be released like this, and it is going to the free space. So in this way, the water analogy is the best example to understand your antenna waves releasing. How the waves are actually going to be released means, if you take that natural example, you can understand it very clearly. Okay, so once you understand this, there is one more answer that is to be unanswered now. That is how these closed loops are going to be formed like this. And that thing we are going to discuss with in the next diagram. So in this diagram, please understand this. Once the disturbance is given to this, once the information is given to this, it is actually forming the alternating electric fields here. It is actually propagating from this place to this place along the transmission line physically, and later it is entering into the free space. So this way you have to understand the detachment of the electromagnetic waves from an antenna. Now I would like to explain how the closed loops are going to be formed. Okay. In order to have the better understanding of the detachment of these electromagnetic waves from this antenna, I would like to explain this mechanism once again by taking short dipole as an example. So if you take, this is the dipole, we are feeding the information at the center, that's why it is a center fed dipole, and I am taking 3 lines of force here for my explanation. So these lines of force are nothing but the electric field lines originating from positive charge and terminating on negative charge. So if I give the information at the center in this form, it is an alternating field here. During this first quarter, that means up to this point, this is the first quarter, I am assuming that the field is positive on the upper side and negative on the lower side, and these are the electric field lines of force originating from this to this. These three lines of force are actually traveled a distance of lambda by 4 from this antenna, because during the first quarter I am telling you, and this is the direction of the lines of force here. Now if you see this input information here, from 0 to t by 4, that means for the quarter, this is the situation you have to understand. From t by 4 to t by 2, that means during this portion, the charge is actually in the reverse direction. It is decreasing now. But already the disturbance is created from 0 to t by 4. That's why if you see this figure at t is equal to t by 2, what is t? Capital T, it is the time period of the input wave. So if you see this figure, the yellow lines are actually the previous lines. These are the lines. And these lines are actually traveled another distance of lambda by 4. That means from this to this, the distance is lambda by 2. So already they have traveled to lambda by 2 distance. And because of this lambda by 4, this is the lambda by 4 input information, then I am assuming another 3 lines are comes into the picture. These are the lines of force coming to the picture in the reverse direction. These dotted lines are indicating for the t by 4 to t by 2. Already from 0 to t by 4, the lines are actually originated and they have gone to the distance of lambda by 2. So now another 3 lines are come to the picture because of this negative energy. Then they are originating from, this is positive now and this is negative now. They are in the reverse direction of the previous lines here. So once you understood that, and once again if you see the input waveform here, and it is actually having positive cycle and a negative cycle. During the positive cycle I explained up to 0 to t by 4 and up to 0 to t by 2 also. And remember friends, this is the t by 2 point here. And at the point of t by 2, what happens here? The charge is 0. It is a transition point from positive to negative here. At this particular point, the charge is 0. That means you should not expect any type of the charge on the antenna terminals. Charge must be equal to 0. So the only alternative is charge has to leave this antenna terminals. That's why this is from t by 4 to t by 2. These are the lines. And from 0 to t by 4, the originated lines are these yellow lines here. Now, this first line is going to form a closed loop with this one, and the second line is with this one, and third line is with this third line like this. That thing actually I have explained here very clearly. So, at t is equal to t by 2, if you understand very clearly, there are 2 colors here. And these 3 colors are actually for t by 2 to t by 4 to t by 2. These are originated at the time of 0 to t by 4. Now, this line is going to form a closed loop with this outer line, and the second one is with the second line here, and the third line is with the third line here. Now there is a formation of the waves. Why they have to leave? Definitely they must leave, because the charge at t is equal to t by 2 on the antenna must be 0. That's why they are forming the closed loops like this. Once they are detached from this antenna, they are becoming free space waves. This is a free space wave, and even you cannot control this free space wave now. So even though the input here at this center fed dipole, even though if you are removed this input here, these waves are already generated here. These waves are going to be propagated forever like this, and up to the destination point they are going on propagating. And if you are giving this information once again, those signals will be generated once again. After that, they will be continuous like this. So in this way, just by taking a short dipole, immediately you can understand there should be a detachment of these electromagnetic waves in the form of the loops. Once you know this, in the next classes, we are going to see the different antenna parameters. Okay, thank you.